Hello everyone, welcome to this video, and in this video we are going to dive into an interesting project, building a simple visual question answering system. So let's get started. First of all, we are going to take a look at the source from where I have taken the dataset. So here's this GitHub code from where I have taken this dataset named easy VQA. So here you can see the complete code, and here's something about the dataset. So it contains 4,000 training images, then 38,575 training questions, then it has test images, test questions, and here are some few sample images of size 64 by 64, and these are few sample questions you can see. So this is the dataset which we are going to use. Now I'll show you the folder. Okay, so this is our folder which contain the data, and it has two folder, test and train. We're going to split the train into again two part in the ratio of 80 by 20, that is training, and second is validation. So inside each folder you have images, here you can see, and you have the questions associated with those images. So here you can see, so it's kind of a simple list. Yeah, here you can see. So this list contain first a question, then the answer, and then the ID associated with the image. So this is basically ID of the image. So here you can see this ID belongs to this image. So this is how it works, and same for the test folder. And here we have this answer.txt. So it basically contain all possible answers that a question can have. So it need to find out which one of it is the best answer for that particular image and the associated question. So this is how it works. Initially, even I am new with this VQA field, so I thought let's learn it and use it somewhere. So initially I used to thought that there is some image, then a question, and it should generate an answer. Now when I started learning it, at initial stage you don't need to generate the answer. You can have few options, and the system need to learn that which of those options have the best answer. This is how it works. Even what I have understood is that you can say it also as a classification problem. Think of it as a classification, just one image, then it has a text as a question, and you combine feature from both these input, and then at last we can generate an output in the form of classification. That's it, because we have all the total options which the answer can take. So these are all the options, and we can simply run a classification kind of algorithm on this. So let's do it. So this is about the data set. Now we're going to write the code for data processing. So we're going to have a function which is going to take the dataset path, and it's going to give us training, validation, and testing dataset, and each of those set would contain training the images path, the questions, and their respective answers. So first of all, we are going to import all the libraries which we require for this task. So I'm going to simply copy paste them. There's no need to write them and take all that time. Next, I'm going to have this line which I'm always use, and I don't know what this line is. Simply, I'm telling the truth. Only thing I know, the execution begins from here. If you write this line, that's all. If you don't write this, it's going to begin with sequence. Maybe I'm incorrect, so you can tell what the correct thing is and in the comments below. So let me now define the main function, and this is where everything is going to begin. So first of all, we're going to have our dataset path. We're going to get it data, because our data is in the same folder. You can have it anywhere else. So now we're going to have another function. We're going to call it get data, and we're going to give it dataset path and say whether it is train or test. So if train is true, it means that you're going to give the training dataset, and if it is false, then it's going to give us the test dataset. So this is how it's going to work. So let me define this function, that is get data, and it's going to take dataset path and train, and its default value is true. Okay, so first of all, we need to say if train equals to true. Okay, not in the quotes. Then we're going to say dataset type, data type. equals to train, else dataset type equals to test. So we simply know which kind of data we are working with. Next, we need to open the JSON file. If you know, I'll show you again. Okay, here I can show you, not the folder I need to show. So each of these contain this JSON file which I need to open. So now let's write the code for that. So let me simply copy paste it. Why writing and wasting time? I'll explain. Okay. So let me just scroll it up. Okay. Now you can see we are opening this file, and here first we have this path. Okay, this is the complete path for the file. First is this data set path, main path. This is data. Then we have data type, what it is, which folder we want to get data from, test or train. This we have here. Then we have questions.json, and this file exists in both with the same name and same extension. So no worry, we're going to read it and we're going to have the data in this data variable. Next, we're going to print this for now, just to see whether things are working or not. Okay. So I'm going to say train, and the name of the file is data.py. Okay, you can see it's working. So it's basically a list. If you see, everything is in a list. First is this question, then its associated answer and the associated image ID. So this is how it works. So what we're going to do, we're going to have a list here. So what we need, first question, then answer, and then image path. So we're going to have 3 empty lists. Now we're going to iterate over our data. So what we do, we have a loop, we're going to iterate over it. Here we have 3 things: question, answer, and the path. Now I print everything just to show you, because seeing first thing, it's easy when we can see and then we can execute, so that we know if there's any error, we get it now at this stage only. You can see question, answer, associated image ID. That's it. So what we need to do, we need to append things here. So in questions.append we say Q, answers.append we say A. Fine. Next is the path, because we don't have the path here, we have just the ID. We need to make sure we have the path. So it's not that simple like question and answer append. It's something like this: image path append. Now here, okay, so this is next I will make sure that my webcam don't gets in between the code. I'll make sure. So here image path dot append, we have this OAuth path dot join. First we have data set, then we have the type. We're going to go with this. Then we have images. Within each test and train folder we have this images folder, and inside we have this ID by the P. We can also say this ID. Let's go with the P only. P means the path, or here path refer to ID, which is in the JSON file, and then we add an extension. So this is how it works. We're gonna get question, answer, and images, and you can see it's much easier to understand now. So let's give these things back. Okay, so this function is going to give question, answer, and the image path, whether it's train or test. So this is how it works, and this is fine for now. Okay, so train and test, we're going to have both here. Now we need to split the data. So let's split it. I'm going to simply paste the code. Here you can say we have this train test split function. I need to work on this thing seriously. Actually, this is my first video and with the webcam. Okay, let's get back to the code. So we have here split the data into training and validation using the function train test split, and here we give it the training question, training answer, and training images path, and the split is 0.2. So this means it's going to divide into 80 and 20%. So training would be 80% and validation would be 20%. So this is how it split the data. Next, if you remember one more thing, we have this answers file. This we need to get this also. So we're gonna write a function which is gonna read this file. Okay, so we have this function get answers label. So we read this file and we get everything as a list. Now let's get these also. I'm gonna call them unique answers, or you can say unique labels also. Whatever you want to call them, it's up to you. Okay, so now this data processing part is done. Okay, so here we are just printing it. We're going to print everything. Okay, so you can see we have training questions 30,860. Then we have in validation we have 7,715 data point, and for the test we have 9,673. Okay, I get stuck. Okay, so this data processing part is done now. Now our next thing would be model, because we are building a simple thing, so our architecture would also be simple. We are not going to complex anything here, just really simple thing that is easy for you and even me for to understand. And then over this simple implementation we're going to improve it slowly and slowly. Okay, like improving the data set first, then improving the architecture. In architecture we're going to improve other component, like for text embedding. For text we can have embedding, but for this video we are not going to use text embedding. We are going to use bag of words technique, which is provided by the TensorFlow itself. So we are not going to complicate anything. So first of all, we're going to import all the library functionality which we require. Then we have a function called build model. So it take images shape, vocab size, the number of vocabulary, the size of vocabulary is 27. Actually I've run this code, so I know. Then number of answers, this is for the last layer, that is the classification, which is going to generate the answer is 13. Now first of all we have our normal CNN network, that is convolutional neural network, which is going to read the image. So first of all we have our image input, it's take the image shape, and after that we have our simple convolution layer, max pooling, ReLU activation. Again we have convolution, max pooling, activation, and then flatten the feature map. And here we have a dense layer. Okay, so this is the feature of the CNN, that is image feature. So x1 basically refer to image features. After that we have our question sub network, which is going to deal with the question. Okay, so we have question input, and this is the shape, vocab size. Now for this implementation we are going to use bag of word. So in the bag of word the size of the input would be fixed, that is 27. It depend upon your vocabulary, the number of word you have in your vocabulary. So it depend upon that. Here in my case these are 27. Maybe it can change, so we'll fix thing accordingly, don't worry about that. So for this things remain fixed. So we have this question input, and then we have two dense layer with 10h as the activation function. Now here you can see x2 is basically text features, the question features, the feature map of the question. Now we're going to combine both the things and build our model. And here we merge, combine both the things. So we simply multiply them. You can multiply them, add them, or concatenate them. It's depend upon you. You can choose anything, because here in this video our task is not to improve the performance. Our task is just simply an implementation which works. Maybe the performance would be low with this type of combination, so it does not matter. The main thing is just the implementation. First it should run, then we're going to optimize it. That is how things begin. So we have multiplied both the features x1 and x2. Then we have again a dense layer with 10h activation. Then at last we have a dense layer with number of answers as the number of feature in this dense layer with a softmax activation. And here we build our model. It take input images and input images and the input questions and give the probability which out of those 13 would be the probable answer. So we have built our model also. Next we need to work on is train. So let's work on the train part. It's also really easy. The main thing in training is to build the training pipeline, which is a bit tricky. Then the rest of the training part is easy. So let me get all the libraries and everything here. Okay, now again, the way I work, I'm gonna have a main file here. I'm gonna copy a few things here. Let me copy them because I believe copying is easy than to write entire code. Okay, let me give a gap here. Okay, now you can see this is our main function. Here we seed it. Seeding basically to make sure that the randomness is fixed. Okay, so that when you run this file you also get the same metrics, same score and everything, just for the reproducibility. This is important. Then we have a folder to store all the files. Next we have some hyperparameters, image size, batch size and number of epoch. Then we have two files, that is model.path. So this is the weight file and this is the CSV file. So in this CSV file it's going to store the training loss, training accuracy and every other thing while training. Next we have our data processing code. This is same from here. Now we're going to save it. Next which we need to work upon is tokenizer. So here's the tokenizer, that is bag of word from the TensorFlow. We have already imported this function tokenizer from TensorFlow keras preprocessing.txt. So it is available. In the upcoming videos we can update this with more improved thing. Now here we have our tokenizer trained on both the training and validation. Then we have a fixed vocab size here. So now here we can print the vocab size. So let's just write the code for main. Let me do it now so that this webcam image does not come in between. So we need to write the training. Okay, we have some got it. That's my mistake. Okay, things are working and we have this function we have not created. That's fine, it's correct. So this is a really simple function. Let's implement that first. So what it does, it takes a path, it check whether this path exists or not, and if it does not exist it's going to create that path or folder in our case. So that's how it works. I hope there is not any other function which we have not implemented yet. Let's run it now. Okay, you can see the training dataset completely, and here you can see 27 refer to the vocab size, the number of word in our vocabulary. So now the vocab part is done. We're going to work on to the dataset pipeline, and that is the most essential thing which you need to understand here. So what I'll do, I'll copy paste the entire code because that is essential. Otherwise if I write this code it would take a lot of time. So let me copy this entire class here and I'll explain each and every part of this and make you understand. Okay, so this is the name of the class, TF dataset. So first of all it takes few things. First is this tokenizer class, the object of the tokenizer class, the labels, that is those 13 probable answers. Next, image height and image width. After that we have this parse function. So just understand this function. It take a single question, its answer and an image path, and it processes those in a form that it can be understood by the model. It can be take as an input by the model. This is how it works. So we decode those things first. Then for question, we convert it into a bag of word using this tokenizer text to matrix. Then we convert it into a numpy array and give it a float 32 type, just to make sure that its data type is float 32. Then we have the answer. So it's a text and we convert it into a one hot array with this answer. So what we do, we create an empty list answers with 0 and with the length of label. So this list would contain 0 element up to 13. That is the length of this self dot labels. And then we set that index to 1, which is the answer. Okay. And this is how we get this answer. Next, we read the image as this as RGB, and I don't think we need to resize the image. Images are already resized, but still, let's assume that maybe images are not resized. Maybe 1 or 2 images by mistake get done here. So we resize them and we normalize the images and we convert it to float 32, and we get our question, answer, and the image. And after that, we have this TF parse function, which is taken by this TensorFlow.data API. So let's first understand this. So here we have a list of the questions, answer, and the images path. Batch size is 16, that is the default size. So we take this tf.data API and we give it everything we have. Now first we have is this map function. So here this map function would execute, it take individual question, answer, and image path, and it's going to use this parse function which we have defined above. Okay, and it's going to get the question, answer, and the image, and we're going to give it back in this form, because we have two inputs. If you remember in the network, image input, question input, and then answer. So this is how it works: image input, question input, and then answer. And then we set batch size, then prefetch, just to fetch some batch sizes in advance, fetch some batches, not batch size, batches in advance. I don't know how it work at the backend, but I hope TensorFlow is there, so it would work fine. Okay, so this part is done. That's the most essential part. Now I'm going to copy the dataset part. I hope it's easy for you to understand. Okay, so now we have this object called ds of the class tf dataset. It take the things, tokenizer, unique answers, the size of the image, and we have two dataset pipeline here for the training and then for the validation. So this is done. If you want me, I can show you like question, image, and then we have answer in train ds. So I can print their shape just to show you. Q dot shape, I dot shape, and A dot shape. Let's not break it. Let me run it. Let's let it run. So you can see this is the size of image. First is this batch size, then we have height, width, and number of channel, then batch size, then size of the bag of word. So each question is converted into this a vector with a length 27. Then we have the answer, batch size, then 13 refer to the one hot vector. This is the size of the one hot vector, that array, where only any one of the index value is 1, rest are 0. So that is how one hot work. So this is working. Next, we're going to build the model and train it. So I'm going to simply copy paste it. So here we have our model, we have compile it, and we have few callbacks. So first this is this model checkpoint. So what it does, it's going to check the validation loss and it's going to save the wait file every time this validation loss get decreases. Next is this reduce LR on plateau. Sometime what happened during training, our validation loss gets stuck, it does not decrease. So what we do, we decrease the learning rate. So with that, performance improve. Third is CSV logger. So what this does, it creates a CSV file and it saves all the training metrics in this file. And at last we have early stopping. Maybe we don't need this in this, but in future videos, just understand it. So what it does, it's a mechanism to stop your training, because you cannot manually, you don't know what should be the time, at what epoch you should stop your training, and it's time consuming. So what we have done is we have a mechanism. So what we do, this early stopping checks your val loss, and let's say for a continuous of 20 epoch the loss does not decrease, so it's automatically going to stop the training. And at last we have our model outfit function. So now we can run this entire thing. Ooh. Yeah, while copying these error occur, and we need to take care of those. I think it's gonna train fine. Yeah, it's not going to take that much time because it's really small data set and does not have that much size. Even image size are small and our architecture is small, so it's really fine. You can see, yeah, you will see here we have our loss, then training accuracy, then validation loss, then val accuracy, and the learning rate. So this is how it's trained. So let me train it for 20 epoch and then we'll work upon the test file. So now you can see the training is completed, and at last our val loss is 0.74. So you can train it more, you get more accuracy. But that's it for our video. Now we'll move on to the test part, and here we will use this test data set and check its performance, and we're going to basically check the accuracy, confusion matrix, and all those things. So first of all, let me get all the libraries which we need. So these are all the libraries function which we require. After that, again our main function, and I'm going to copy entire code. Yeah, let me copy the complete code and explain to you line by line. Yeah, I know this is not good to just copy entire code at once. So we'll move from start. So here is our main function, from where we start the seeding first, just for the reproducibility. Then we have our hyper parameters, and maybe we don't require these two. Let's remove them. Then our model path, basically the weight file. Okay, and this is our data processing, and here we only need the test part, that is test question, test answer, and test images. Next we have our tokenizer. After that we load our model, and now comes the main thing for the performance check. Here we have two lists. First is true value, second is spread value. So what we're going to do, for each image and question pair, we're going to have its true value save in this list and the predicted value save in this list. And when this entire thing is done, we're going to move on to the this check part. We're going to have some metrics and we're going to evaluate the function, those things. So here we have a list, and we iterate over this list which contain test question, test answer, and test images. So first is this question, because if you see what we have done, we have already converted these questions, this test question, to bag of word. So we just need this. So this list test queue contain all the questions in bag of word form. They are already encoded in bag of word. So we just get this question, and we need to expand its dimension, because the input is going to be in a batches, and here we don't have any batch. So in this, every iteration, it's going to be batch of one input only. Okay, each batch would only contain one item. So we have this question here, then we have this answer. Okay, the unique answer dot index. So we get the index number of our answer. So this is a text, still this is text. Then we have true value appended into this list. Next, we're going to read the image, process it, and do all sort of stuff required for it. This is same as which we have done in training. This whole thing is same. Now comes our prediction part. We have our image, we have our question, and we have our prediction here. So for prediction, because it's a soft max, we have probability over 13 options. So what we're going to do, we're going to run np.argmax, give us the index number of the index number which have maximum probability. This is how softmax work, and we get our index number in this pred, and we append it to the pred values. So this is till here. We have this loop, and after this loop we're going to have this classification report based on true values and the predicted value. We're going to print this classification report. Then we have confusion matrix, and we save this confusion matrix as a heat map. So let me run this file. So this is really simple in itself. Okay, yeah, it's going to take some time to run. You can see this execution begins. So it's going to take near about 4 minutes and 10. I'll pause the video and I'll open it, and we'll continue when this complete. So you can see the training is completed, and here we have our classification report. So these are all the options, and you can see the precision, recall, F1, everything is 0 because the training is not yet done. You can see this is fine. So you need to train it more and then work upon it. Okay, so now we'll see about the heat map. So this is the heat map which we have. Yeah, it need more training because you can see a lot of values here and there. Yeah, so that's the training which you have done in this video. I want you to train it more and get better performance. And if you have any error in the code, then you can please comment it down. I'll try to find some time and answer you, because see, I have many other things to do beside this YouTube channel. That's why I cannot be consistent on it, because a lot of work is there. So I hope you now understand the basics about visual question answer, and you can implement it with some basic data set. So that's all for this video, and please do make sure to like, share and subscribe the channel, and hit that bell icon for more such informative videos. Thank you and have a nice day.